right, so today we're going to talk about something called completing the square. All right, students will solve quadratic equations by completing the square. Now, we want to do this for problems that aren't set up in our normal form like we did when we were graphing. All right, so we want to look and see how can we complete the square. Well, if we were to multiply this out and then subtract the 5 over, we wouldn't be able to factor it, and so then you would not be able to find values for x. So we're going to do something called completing the square. So the first thing we're going to do is we're going to try to solve for x. Well, if you have x plus 3 quantity squared equals 5, you can take the square root of both sides, so that way we can solve for x. So we have x plus 3 equals plus or minus the square root of 5. And then we're just going to subtract that 3 to the other side. So x is negative 3 plus the square root of 5 or negative 3 minus the square root of 5. So there are two answers, just like when we factor. There are two answers, and the reason we have two answers is because we have the exponent of 2 there. If the exponent was 3, we would have 3 answers. So we have 2 answers here. If you want to leave it in this form, that's fine, because that implies that you have negative 3 plus the square root of 5 and negative 3 minus the square root of 5. All right, so now let's take a look at example 2. All right, so this one's a little bit different in that we need to factor it first. Again, if we were to add that 2 over, we would end up with a 6, and then we would not be able to factor it that way. But here, if we factor this, we notice that it's x minus 2 quantity squared. So then we can take the square root of both sides again, just like we did with the first example. And so we get x minus 2 equals plus or minus, don't forget that plus or minus, square root of negative 2. All right, so now we can move our 2 over. So we get positive 2 plus or minus, and then remember when we take the square root of a negative, we've got to pull out that I. So we have I square root of 2. And again, you can leave it like this, or you can say x equals 2 plus I square root of 2, or 2 minus I square root of 2. So you should always have 2 answers whenever you have an x squared. Now those 2 answers might be the same, they might be different. Regardless, you have 2 answers. All right, so let's take a look at example 3. All right, so example 3, we have a squared minus 5a plus 3 equals 0. Now, this equation is not factorable, so we have to figure out a different way to solve this problem. And what we're going to do is what's called completing the square. So we have a squared minus 5a, and we're going to subtract that 3 to the other side, so that equals negative 3. Now, when we complete the square, we take half this middle term. So we have negative 5 over 2. Forget about the a. We're just taking half of that coefficient, not half the middle term. Half the coefficient, and then we're going to square that. Okay? So that becomes 25 over 4. And so now we're going to add that to both sides. So plus 25 fourths plus 25 fourths. Because if we add that to both sides, we're not changing the value of the equation. Okay, so now we can go ahead and factor this side because it's now a perfect square trinomial. So we have a minus 5 halves quantity squared, and we know that that is this trinomial factored because if you square this, you get 25 fourths, which is this term, and if you multiply these two together and then double it, you get negative 5a. So we know that we factored correctly. And then we can combine these two. So this becomes negative 12 fourths plus 25 fourths. Okay? So we have a minus 5 halves, quantity squared, equals 13 fourths. Then we need to take the square root of both sides, just like we did for examples 1 and 2. Don't forget your plus or minus here. So we have a minus 5 halves equals plus or minus square root of 13, and then we can take the square root of 4. That just becomes 2. And then our last step is to add that 5 halves over. So we have a equals 5 halves plus or minus square root of 13 halves. Now you can rewrite that as 5 plus the square root of 13 all over 2, or 5 minus the square root of 13 all over 2. You have two answers. Remember, we have two answers. Anytime you have x squared or a squared, the variables being squared, you have two answers. So there are your two answers. Now let's try example 4. It's a little bit different from example 3 because now we have a leading coefficient. So the first step we want to do is divide everything by that leading coefficient. So we divide everything by 7. Okay. Then we want to get this number to the other side, so we subtract it. Rewrite that as x, or 8 over 7 times x. All right, so now we're doing the same steps that we just did in example 3. We just have more fractions here. So we're going to take half the coefficient here. So we have negative 8 over 14 because that's half. And then we're going to square that. Now what I would suggest is simplify it before you square it. That'll just make it a little bit easier. So that becomes negative 4/7. And then when you square that, it becomes 16/49. Okay, that just makes it a little bit easier to deal with. Otherwise, we'd have really big numbers. Okay, so that is what we're going to plug in over here. So now we're going to add that to both sides. And now we have a perfect square trinomial over here, so we can go ahead and factor that. So we have x minus, and then this 4/7 quantity squared, and then we can simplify this. So we're going to multiply by 7 over 7 here. So we have negative 21 plus 16 all over 49. Okay, and now we'll just combine those. So we get negative 5 over 49. Let's roll this up a little. Okay, now we're going to take the square root of both sides. Don't forget your plus or minus. So we have x minus 4/7. And then equals plus or minus the square root of negative 5 over 7, because we can take the square root of that 49. Now we're going to add the 4/7 over, plus or minus, and we can pull out the I here. All right, so I would write the answer like this. X equals 4 plus I square root of 5 all over 7, or 4 minus I square root of 5 all over 7. That way we remember that there are two answers to this problem. And that is how you complete